Good morning, my dear students. Today we are going to start class 9 physics. Topic is energy. Already what that topic we learned. Here today we are going to learn which energy. We know that what is energy because in our daily routine we are doing some activity, different types of activity, like we are reading, somewhere are cutting the wood, cutting woods, some are washing the clothes, like this. Students are reading, walking, playing, different activities we are doing in our daily routine. But see here, for doing all these activities, we need some effort. And this effort is known as what is? Effort means we need some strength. And this strength is known as what is? Energy. This strength is known as energy. Clear? That means the activity which we are doing in our daily routine. For this activity, we need some energy, we need some strength or some effort. That effort or that strength is known as energy. So there are different types of energy we need for different types of work or different types of activity. For muscular energy, muscular strength, for muscular activity or muscular activity, we need which one? Muscular work, we need muscular energy. Similarly, for mechanical work, we need mechanical energy. For electrical work, we need electrical energy. Yes or no? Why? Because when we are doing some activity, that means in this case, work has to be done. For work, we need some strength or we need some effort. That effort is known as energy. And for different activity or different work, we need different energy. Like this muscular work, we need muscular energy. Mechanical work, mechanical energy. For electrical work, electrical energy. This type of different types of energy we need. So therefore, we can define energy. Energy is defined as the ability of doing work. That is known as what is energy. Clear this one? And because the doing work, the ability of doing work is energy, therefore its unit, SI unit. Which unit? SI unit is also equal to the unit of work. Because we know that unit of work is what is joule, therefore unit of energy also joule. And there are different types of units. That means smaller unit, bigger unit. So what is the bigger unit? Bigger units are what is it? Kilojoule. One is kilojoule, megajoule, and gigajoule. And the relation between joule and kilojoule, megajoule or gigajoule is 1 kilojoule is equal to 10 raised to 3 joule. Megajoule is 10 to the power 9, 10 raised to the power 9 joule, and gigajoule is 10 to the power 6 joule. Clear this one? And there are different forms of energy. Different forms of energy. Heat energy, tidal energy, green energy, geothermal energy, heat energy, like this. Different types of work are there. But here we will discuss, mainly we will discuss mechanical energy. Mechanical energy. So you know that different types of form of energy, like which one? Electrical energy, tidal energy, wind energy, water energy, geothermal energy, waves energy, wind energy, nuclear energy. Different forms of energies are there. But mainly in this chapter we will discuss which energy? Mechanical energy. So what is the mechanical energy? It is the energy produced by the virtue of the body, virtue of position or motion by the body. That means this energy, this mechanical energy is the energy which is possessed by the body by its position or motion. That is known as which one? Mechanical energy. And this mechanical energy is two types. One is known as potential energy. Potential energy. And second one is kinetic energy. Kinetic energy. So in this case, we can define here potential energy. Short form we can write E, or this is we can write KE. Potential energy and kinetic energy. So what is potential energy? Potential energy is the energy which is possessed by virtue of its position. That means its energy is position. The potential energy is produced or potential energy possessed by the body by the virtue of its position. Suppose this is the table. Suppose this is one table, and on the table there is a book. Book is there. That means in this case, this book is having, because it is at rest position. That means in this case, this book is having potential energy because it is at rest. Due to this position, it gives the potential energy. And this potential energy is calculated, or it is calculated by W is equal to mgh, or potential energy. We can write here mgh, potential energy. How it is derived? See here. Suppose mass of this book is m, and it is this book is create an acceleration. That acceleration is due to which one? Due to Earth, and that is g, and it is at the height, this height or distance, that is h distance. Therefore, this potential energy is, we can write, that is mgh. Second thing, what is kinetic energy? Kinetic energy is the energy which is possessed by the body by virtue of its motion. That type of energy is known as which one? Kinetic energy. Now we will derive the daily expression for kinetic energy. And this kinetic energy is K E is equal to half mv square. So this kinetic energy we will derive now. See here. How we will derive the expression for kinetic energy? Derivation or expression for kinetic energy. Clear this one? See here. Suppose this is the object. This object, mass of object is m. Suppose its initial velocity. Suppose we will take initial velocity we will take, suppose capital F, capital V. So after covering s distance, after covering how much distance? S distance, this object is stopped. This object is stopped here. That means in this case, the final velocity, suppose that is small v, that is become 0. So in this case, how we can calculate the kinetic energy? Because see here, already given. Consider mass of object is how much? Object is m, distance covered is s distance, s meter suppose, or s distance, and its initial velocity is capital V, meter per second, and we know the final velocity that is small v is equal to 0, because this object is going to stop here, therefore final velocity is become 0. So we know that from third law of motion, equation of motion. What is third law? Third law is, we know that v square is equal to u square plus 2as. So this is what is? This is final velocity. This is initial velocity. See here, initial velocity, we are taking small v. So in this case, final velocity is 0. 0 is equal to v square plus 2 into a. A means acceleration, because this object is going to stop here. Therefore, acceleration is which acceleration? This acceleration is minus a. Therefore, in this case, we can write here minus a into s. Distance is s. So in this case, we can write here that implies 0 is equal to v square minus 2as. So that means v square is equal to 2as. Therefore here a is equal to how much? A is equal to v square upon 2s. Clear this one? Suppose this is equation 1. Again we will take the help of what is second equation of motion. We know that what is second equation of motion? Second equation of motion is what is F is equal to ma. Clear this one? So in this case we can put here F is equal to m into, instead of a we can put this value, that means b square upon 2as, only 2s. Instead of a we can put only 2s. Suppose this is equation 2. Clear this one? But we know that what is we know? We know that this F is equal to ma. F is equal to how much? Ma. F is equal to W is equal to, so work done, W is equal to F into S. We know that. That means in this case, what is F is equal to how much? F is equal to M into, this is V square upon 2S. V square upon 2s into how much? Into S. S means this distance S. So S should be cancelled. Therefore, work is equal to what is energy. Therefore, this kinetic energy is equal to, we can take half this one, 1/2 into mv square. So like this you can derive the expression for kinetic energy. So now we will do one problem, then you can understand. Now we will discuss one question here. See, a question is given, the kinetic energy of an object of mass is given m. That means mass of the object is given, mass of object is m, moving with a velocity of 5 meter per second. Suppose this is v1 is given 5 meter per second and is joule 25 joule. That means its kinetic energy is how much? Kinetic energy, suppose 1, it is suppose given 25 joule. Note this one. And question is asking, first question is what will be its kinetic energy? Suppose this kinetic energy is 2 and its kinetic energy is suppose 3. What will be its kinetic energy when its velocity is become double? First question. That means in this case v1 is given 5 meter per second, but when velocity become double, that means in this case v2 become how much? Double means how much? It is given 5 meter per second into 2, that is 10 meter per second. So in this case we have to calculate kinetic energy. Clear this one? Because we know that kinetic energy is the energy which is possessed by virtue of motion. That means this kinetic energy is when motion is increases. That means velocity is increases, then kinetic energy also increases. If motion is decreases, kinetic energy also decreases. That means this kinetic energy is directly proportional to the velocity of the object. So in this case we can write this here. We know that what is kinetic energy 1 is directly proportional to v1 square of the velocity, and kinetic energy 2, it is also directly proportional to v2 square. Clear this one? So from these two we can write kinetic energy of 1 upon kinetic energy upon 2, it is become how much? v1 square upon v2 square. So already we know that kinetic energy of 1 is how much? 25 joule upon kinetic energy 2 is equal to v1. v1 is how much? v1 is 5 meter per second. The square of this one means 5 square of 5 is 25 meter per second upon v2 square. v2 is how much? v2 is 10 meter per second. 10 square is 100. So in this case we can calculate kinetic energy 2 is equal to how much? This is become 100 into 25 upon 25. So this will be cancelled. Therefore kinetic energy 2 it is become how much? 100 joule. Clear this one? So like this you can calculate what will be its kinetic energy when its velocity become 3 times. That means in this case v3 became how much? 3 times. 5 into 3, that is 15 meter per second. So in this case we can calculate kinetic energy 1 upon kinetic energy 3 is equal to v1 square upon v3 square. So like this you can calculate. This is given how much? 25 upon kinetic energy 3 is equal to v1 square. 5 square is 25 upon v2 square. 15 square. 15 square is how much? 15 square is 225. So finally we will get how much? Kinetic energy 3 is equal to 225 into 25 upon 25. So this will be cancelled. Therefore kinetic energy of 3 is equal to how much? 225 joule. Clear this one? So like this you can calculate. You will solve some more numerical problem, and if any doubt you should contact me. Next class we will conduct the conservation of and a law of conservation of energy. Thank you.